Well, I've been looking forward to making this episode for quite a while now because that means that we finally have all of the pieces to put the finishing touches on the engine block. Anything else from here we can do with the engine in the engine bay, but prior to these parts, I've effectively been holding back putting the engine in the engine bay because it's going to be so much easier to do it with the engine out for various reasons, which we can get into. Starting off with first, getting the engine timed. We finally got the LPSFAB Manual Tensioner Kit, which I've effectively been putting this specific portion off until I could get my hands on it. In addition to that, we have the majority of our fluid lines for the coolant and oil returns for the turbo. So let's go over the LPSFAB timing kit, and then we can get into the process of timing the engine. But I can first show you the differences between the timing kit that I currently have, which is from Integrated Engineering, which I've said it in the past, it's not a bad unit and it works. I just like the LPSFAB much, much better, and then we can start working on our fluid lines. So I'm going to continue to overstate myself with the fact that there's absolutely nothing wrong with this timing kit. It is the timing kit that I've been running for the last 7-8 years, the life of this built engine. So obviously there's nothing wrong with it. So if this is something that you are looking at or have, there isn't anything that you really need to worry about. It obviously works. But there's a design hesitation for me personally to kind of go over how this one works. It's pretty simple. You have this offset set screw here, and that allows you to rotate the tensioner to give you the appropriate amount of tension on the timing belt. But one, you are solely relying on the singular nut to hold your entire timing setup. But as far as the design, it doesn't give me that peace of mind. And again, that is a me issue. Second issue that I have with this is over the life of the timing belt's operation, it's going to stretch a little bit. So you do have to adjust the tension as you go because you're not dealing with a hydraulic tensioner that is adjusting the tension and giving you the appropriate amount of tension as the belt stretches naturally. So with that being said, you've got your engine mount right here. Your motor mount then goes right here. You can't get to the nut in a convenient way to appropriately torque it or do any of that without having to unbolt the engine, lift it up a little bit, and then get your socket and everything. So those are my primary two reasons as to why I've been wanting to get this LPSFAB kit. So let's rip this one out and we'll get the new one installed, and I'll tell you exactly what I love about it. Most of it's going to be pretty apparent. So now some of you might be able to already see some of the design differences here and why I appreciate this one a little bit more. For starters, and the obvious bit, it utilizes a factory tensioner or tensioner pulley. So this is free to spin. It does not get torqued down like the previous one, which is where this design shines. So similar to the factory design, you would have a hydraulic tensioner here, and the hydraulic fluid would push up against this and onto the belt. So then the belt pushes against, the tensioner pushes up, and that's where you get your tension. Now with this one, you have a set screw that you can adjust, and you can see how it moves. And then with that set screw, you can then run the locking nut, lock this down, and you're set. So tensioning mechanism, wildly different, and put on the idler pulley, I guess, bracket, in a similar fashion as the OEM. So let's get these things torqued down and let's move on to putting the timing belt on finally. And I can go through a few tricks because this does tend to be a little tricky for some people. So I've got a few tricks up my sleeve. Nothing crazy, you've probably seen it on the internet, but we'll go over here. So to go over timing really briefly, if this is something that, first time, you're not exactly sure what it is, you just know that it has to be done. In a nutshell, you've got the bottom end of the engine block, which is crankshaft, pistons, rods, all of that. That is timed by the crankshaft mechanism here, this gear. And then you have the top end, your cylinder head. So your valves and your camshafts and everything, those need to be timed. And what we're doing is we're making sure that the top end and the bottom end are in sync. Otherwise, you have mechanical components hitting each other, and that's kind of it. It's done and over with there. So there's a few ways to do this. Normally, if you're taking apart the original engine and you're just doing a belt replacement, it's really easy to make a mark on the old belt on the bottom timing mark, and then on the top part of the timing mark, and just transfer it over to your new belt. But if you're doing this completely clean, you don't have a previous belt to reference, none of that, and you need to figure out what's going on, well, there's a few marks that you can follow. For the cylinder head, this one's the easiest. You've got a timing mark on your cam gear here. Now on our engine specifically, it's a dual overhead cam, but we have a singular cam gear. And that's because the exhaust cam on the back side has a gear that runs a chain to the intake shaft. So the cams time themselves. So that's one timing mechanism. Most of the time, you don't really have to mess with that unless you're modifying it. And then this is just running a sensor to reference its position. So we only have to worry about one gear rather than two gears here. And then on the bottom, you also have another timing mark. Now, I'm gonna go over like a worst case scenario. Let's say like in a situation like mine, I did some cylinder head work. The bottom end, you know, I've rotated it around a bunch of times. So let's say we have no idea where top dead center is. There's a way where we can do this mechanically and have a visual representation. So every engine's a little bit different. So if you're watching and you don't own a 1.8T, but you're still trying to understand how to do all of this, just reference your timing marks. The concept is effectively the same. But what we're trying to do here first, because this is done in two parts. The first part is we're going to want to put our timing cover for this bottom portion, because that's where our timing mark is located, is on the timing cover here. And then we'll want to put our pulley, which also has the timing mark on it. The cam gear has a timing mark as well. That references our pulley. So let's do this part first. And I've marked mine with a silver paint pen. I usually do this every single time that it starts to wear off. And you can see it right up there. Without the silver mark, there's just a line, there's a divot in there. But it can be kind of hard to see, especially once the engine is in a car and you know, you're just trying to do this in situ. So we'll do this part first, and it doesn't have to be tight or anything. But down here, there is a little boss that sticks out, and that will go on our pulley here. You can see it there, and then there's also a timing mark on there. Now I've already gone and made sure that mine is situated where it needs to be. But what we're looking at here is matching the timing mark on the pulley to the timing mark on the cover here. That way we know that the top of the piston is at its topmost point, ready to go down and start the cycle as it should. Now what you're gonna do is you're gonna come up to the top. I would recommend taking out all of the spark plugs so then you're not fighting compression. And then I would put like a really long screwdriver, an extension, basically anything that you can use as a visual reference to see it rise and fall. Because again, what we're looking for is we're looking for the piston for cylinder number 1, which is always going to be the one closest to the timing side. It is at its absolute peak. And then to verify all of this, you're going to put your wrench on the crank bolt on the bottom. And now we're going to verify that rotating clockwise or counterclockwise will only make this fall. And I'm going to go do that right now. So I'm going to pull it clockwise, so in standard rotation, and it immediately starts to go down. Now we're going to bring the crank bolt or the crankshaft back up to the timing mark, and there we are. So then I'm going to go counterclockwise, and it should only fall again. And there it goes. Some people might freak out about, oh no, don't rotate it counterclockwise, you're going to ruin your bearings, whatever. No, you're not. It's perfectly fine. The amount of times that the engine kind of counter rotates when it's turning off, does it all the time. It's not a big deal. From there, we can move on to timing the cylinder head, which in the case of our 1.8Ts, it is really easy because the cam gear itself is going to have a timing mark, and that's whether you have a factory one or an aftermarket one. And then the valve cover will also have a notch on it to notate where the timing mark should align. Now my aftermarket one didn't have one, so I put one there in reference to the original one. But the factory one does have a very clear mark, which in the past I have also used a paint pen to just mark it to make it a little bit more obvious. So let's go over to the workbench real quick and I'll show you a quick little trick on being able to get your timing belt marked and ready to just throw on. So if you're familiar at all or you surround yourself in the 1.8T community, probably the first thing you'll notice is that I'm running a standard Continental timing belt as opposed to the blue Kevlar belt. I prefer these 10 out of 10 times over the blue Kevlars because these have a little bit of stretch, they have a longer service life, and they're more than capable of handling the torque on a lot of high power builds. This is what I've run exclusively, and I personally don't recommend the blue Kevlar, primarily because all you're really getting out of it is a shorter life span out of it and a shorter maintenance interval, which I mean is kind of dumb in my opinion. The benefits do not outweigh the cons. So that's the first thing. And then the second thing, you'll notice that I have two very clear marks here. This one being tooth number 1 and this being tooth number 68. So let's go bring this over to the engine and I will tell you exactly what that means, but it makes putting the belt on infinitely easier and a lot quicker. So now we can come to our engine and we can put it all together. So now that we know that the cam sprocket and the crank sprocket are in time, now we can just bring our marked timing belt. We can do very brainless work because we've got our two marks notating the timing position for the cam and the timing position for the crank. So we can just lay the belt on. Tooth number 1 on the belt is going to be right in front of the timing mark because the timing mark is on the tooth on the cam sprocket. So the first tooth on the belt is going to be right in front of that mark. And then we can carry our belt down. And this is just kind of the part where you're just going to have to fight it because the tension is effectively on this backside and the teeth count has to be exact on this side. So obviously you're going to be fighting with it for a little bit. And what we want to make sure is that we get tooth number 68 in front of the timing mark on the sprocket. So I think what I'm going to do here is I'm actually going to take this pulley off because I'd rather fight the pulley than fight the belt. So we'll just make sure that that's all situated there. And there you go, it's that easy. So now we've got all of this bolted up and installed. So the final piece is now to verify. Again, with the spark plugs completely removed, that way you're not fighting compression, what we're gonna do is we're just gonna rotate this an entire cycle. The belt isn't going to fall back into the same area, but what we do wanna verify is that our timing mark, when we reach top dead center as notated by the crank, that it is also top dead center up here on the cam. So let's go ahead and start rotating. So that's one rotation. And there's 2. The timing mark on our gear here is lined up with our timing mark on the cover, and our timing mark on the sprocket lines up with our timing mark on the valve cover. So that is how we can verify that now we have everything 100% in time, which is beautiful, and it makes this whole thing really, really easy. But yeah, so with that done, now we can go ahead and start moving on to the last piece here, where we can start running our lines, and then we can get ready to throw this thing in the engine bay. So now that we got the engine all timed, we can move on to the final piece of the puzzle, which is getting all of our lines done for the turbocharger. The primary focus is going to be the coolant feed line, which comes from the back of the block and goes to the front of the turbo. So that one's going to be the trickiest one to do. The rest of them we should be able to get, fly through. But let's go on over to the bench. I'll show you what we've got, and I'll also show you how to make some AN lines, since I haven't really done that in a long time. So let's head over there and we'll take a look. So I'm sure most of you, if not all of you, have probably heard of an AN line before. If you haven't, or you have and you're just not quite sure what these are exactly, I'll give you a quick little crash course. So first things first, this is a self-sealing design. You can find them in all shapes and sizes and pretty much for any fluid application. Now in front of me, I have dash 4 AN fittings, and these are going to be for our oil feed. and then some -6 fittings, which are going to be for our coolant feed and returns. Like most fittings, you're going to have a male and female side. The male side has a flare, and then the female side on the inside of the screw here has the joining side. When you screw these together, these do not require a whole lot of torque. Actually, you ruin them if you tighten them too tightly, which is kind of nice. You just give them a nice little hand turn, and the tension on the screw will prevent it from coming loose, and the flares mating create a completely sealed system. So your fluids run through no problem, and then when you need to run some maintenance, whatever the case, you need to come in and take it apart. A quick little turn, breaks it loose, and apart they come. Saves from working with pesky worm clamps and less desirable methods of putting hoses together, especially when you're in and out of the engine, or in my case, you're doing maintenance, upgrades, things like that, relocating stuff. It's really nice to have something that's really quick to come apart. Now, to build the hoses with these, they're quite easy. So your fittings will always come in 2 pieces, at least the ones that will house your hoses. You've got your main fitting, and then you've got a collar that screws on. In this case, you just take your hose. You'll want to put your collar on first, which we'll do here in a moment. It gets a little tricky, you kind of have to fight it. You put your collar on, and then you slide this inside of the hose, and then once you mate the 2 pieces together, you just screw them on. They don't screw on that easily, but once you screw them on, the hose gets pinched inside, and you've got about that much hose that's within the fitting, inside the collar. It's press fit, and again, they don't come loose, they don't leak, and it makes things really convenient. So let's go ahead and start putting some together. I do want to put our coolant feed, like I said. We'll do that one first, and we'll kind of go from there. I'll show you a few tricks on how to put these together a little bit easier. So the first thing we want to do is, so we're going to grab our 90 here. This is going to be our first line. Here is my 6AN rubber hose. So this is stainless steel braided, but it has a nylon braid over it. And then it's a rubber core. So obviously when you buy your lines, you're going to have 2 ends. If you have the luxury of getting one that has less frays, choose that one, because this is going to be a nightmare to play with. So we're going to start here. Now the very first thing we do is we put our collar on. Now the reason we want to get the one with the least amount of fraying is because while this does have somewhat of a flare on the fitting to go over the hose itself, any amount of fraying that sticks on the outside is going to fight you, and as you try to put this in further and further, the nylon is going to start undoing itself, and it's going to create an absolute mess. Now some people put some tape around it. I've done that in the past. It doesn't always work, and the reason for that is because when you're actually trying to remove the tape, it's actually going to pull the nylon off, which kind of defeats the purpose. So I've just resorted to fighting it. I start with the most frayed end, and then we kind of just twist around, and this can go any which way. This could go very well, very easily, or it could go very, very poorly. I also like to use a flathead screwdriver to kind of help me push the frayed ends in. But let me fight with this here for a moment and get this on, and we will be right back. All right, and there we go. So this is honestly the worst part about making AN lines. They do make tools for this. They're quite expensive, but you can still make them this way. It's no big deal. Now, before we slide this in and screw it on, there is a trick that I learned that makes this infinitely easier, because this is also another tough part. Not as hard as putting the collar on, but that's putting either dielectric grease or putting some kind of silicone lubricant on this to slide into the hose easily. So I'm going to use dielectric grease real quick, and that'll allow us to slide it in to at least get our threads started, and then we'll start the tightening process. So now from here, just get it slid in and started. And then you just screw it on. And then you're going to get to a point where you meet some solid resistance. So that's where you get your Allen wrench. And just screw it on. Now, word of advice, you can use a standard box wrench. However, because these are aluminum fittings, it is very, very easy to mar the fitting itself with one of these. So I'm going to do it anyway here, but that's just a word of caution because it can happen. So if you are worried about how the fitting looks, just keep that in mind. Should probably flip this the other way. And then you just keep on twisting until both fittings just bottom out on each other. And there we go. So now comes the fun part where we start test fitting some things so we can get our length. So I'm gonna put, this is our coolant feed bung. Goes in the back of the block. And this is why I was saying that it's going to be a little bit tricky, because we've got to run our line up through here so it feeds from the back of the block, goes on up and over, and then into the front of the turbo. Now, that's how I ran it on my other setup as well, so it's not that foreign. It's just that this setup is thicker in just about every way. So our clearances are a little bit smaller and a little bit tighter, but I think we can still make do. And then with the hose that we just made, we're going to screw it onto the front here. And then what I'm going to do is I'm going to run it, give it a little twist. I think I'm probably going to put some kind of holder for the hose here. I've got some things to consider as far as making sure that it doesn't do this, but I can figure that out later. I'm going to run some tape. There we go. And then we're going to take this back to the workbench. There's a few ways to cut these. I have a special tool to cut these with, which is super convenient, but you can do it with the Dremel, you can do it with a bunch of other tools. They're really thick, and like I said, they're steel braided behind this nylon, so just keep that in mind. But let's take this out and go to the bench. So now this is a bit more of a relatively expensive tool, not terribly expensive, but it's a specialty tool in this case, but well worth it. Like I said, you can use a Dremel. I used to use a Dremel in the past, but these have made it infinitely easier. But what we're going to do here is we're going to get our hose situated. We're going to get like right around center. We want to try to make as clean of a straight cut as possible. And just like that, sliced up. Now let's head back over to the engine and test out our length. And then we will just press fit this on for now. But I'm happy with this length. We're not looking at any kinking or anything like that. I do plan to get a turbo blanket as well, so we've got enough clearance there. It goes right past the exhaust runners with a lot of clearance as well, and same with the downpipe section here, especially with, I believe it'll probably be closer to something like that. I'll have to figure out a way to support the hose so it is probably right around here where any vibrations or anything like that won't cause it to rub up against the cylinder head, nor will it rub up against here. So I am going to consider this line effectively done. Now I'm not going to finish off the ends on actually any of them because I have some silicone sleeves for each of these lines coming. They are unfortunately stuck at customs, so I don't anticipate them to show up anytime soon before this episode wraps up. But this is the part that we primarily needed to get done. So I'm going to get the one side done on all of the lines. I'm going to whip those out real quick. You know, you don't need to see me struggling to make identical lines all throughout. So let's get those knocked out and see how this looks. I only had to redo one line, which wasn't too bad, but that was just due to preemptively cutting its length before I verified, which would make sense. This one's our coolant return. We've got the We've got the coolant ball that'll go right here, and then I'll have to tie this in here, similarly to how I had it in my previous setup. So this is the one that I cut too short initially, but that one will go there. And then our oil feed. That is pretty much it. The rest, you know, we can figure out once the engine is in the car. But this was the main thing, getting the timing and then getting this line primarily figured out. These ones I could have done either or, but since we're here, got them situated and figured out. Man, I'm excited. We can get ready to slap everything on, put it in the engine bay, and yeah, start, I guess, finishing touches. I mean, there's going to be some fabrication that we're going to have to do with our new housing here for the turbo, for the compressor. But yeah, one step at a time, but at least one step closer. Well, that's all I have for today. I know that this one was a little bit more word heavy with getting the timing and everything else situated. Hopefully it is something that is helpful for some of you though. It's kind of the whole point. But otherwise, next time you see this engine, we're pretty much going to be ready to toss it into the engine bay. Our sleeves should be here and everything, so the lines will be all done and everything. But then we can start getting all the final fitment and things like that to you know, get us that much closer to the first startup. So we're making some good progress. I'm happy with where we're at, and I'll catch you guys in the next episode.